Oh, good morning, everyone, and thank you for joining us on our policy webinar series. I'm John Wertman. I'm Esri's Program Manager for Public Policy, and I'm joined today by my colleague Bonnie Stayer, who's our Solution Engineer and Policy Team Lead. In today's webinar, Bonnie is going to provide an overview of conducting spatial analysis for public policy using our tools, which enable powerful insights for policymakers. I'll now turn it over to Bonnie for today's presentation.
All right, thanks, John. Welcome to this webinar. To get started, I wanted to begin by asking why GIS in general as a policymaker. Why would you want to use GIS? And really this comes down to the fact that to understand a problem or issue enough to make policy about it, it's useful to think holistically. And GIS really helps you to do that by giving you the ability to integrate multiple different types of data and break down data and contextual silos that we often find ourselves working in. So we can examine multiple layers of information, data from different contexts, and also get a multi-scale perspective on an issue, both macro and micro scale. So it's common for people that are researching policy to maybe study via one method or one context, but GIS is really useful in developing that overarching perspective. So the key component of GIS that allows us to do that is spatial analysis. So a GIS is broader than just spatial analysis, but the analysis portion is really what allows us to break down these silos and integrate these multiple layers of information. So if we were going to give a definition of spatial analysis, this is one sort of more formal definition. We can call it the process of examining the locations, attributes, and relationships of features in spatial data through overlay and other analytical techniques in order to address a question or gain useful knowledge. Spatial analysis extracts or creates new information from spatial data. Now, obviously, again, that's a wordy, more formal definition. Another way of thinking of it is just really what humans do naturally. When we integrate spatial data, we're trying to understand our world. We're mapping where things are, how they relate, what it all means, and what actions to take based on that information. And again, this is something we as humans naturally do. When we look at a map, we begin trying to interpret it and interpret trends and patterns and deriving an analysis or an interpretation of that map. So I like to think of it even more simply that spatial analysis is really about solving problems or answering questions. So oftentimes when we're helping our users make best use of the technology and they're asking us, what tool should I use or how should I do this? I ask back to them, well, what is the question that you're trying to answer? Because then we can translate that into a spatial analysis and therefore a tool or component of the product to use. So these are some examples of questions that spatial analysis can answer. One classic one is, where is the best location for a store? Anytime someone from my family asks what GIS is or what I do for a living, this is typically the answer that I give, where you need to integrate, again, multiple types of data, including where populations are, distance to access roads, cost of land, distance to competitors. These are all multiple things that you want to include in determining the best location for a store. Another example is, what is the closest fire hydrant to each building? So this is a proximity analysis. And so we can do that, based on just pure straight line distance, or maybe it's along a road network when we need to consider some of these proximity questions. What is the fastest route over rugged terrain? So when we don't have necessarily a network to follow, we just want to go based on the elevation or the slope or the soil type of a given area. How do we ensure that we can route safely throughout a terrain? And how many people are within a contamination zone or really any other area of interest? So again, being able to map demographics and summarize the characteristics of the population within a given area. These are all spatial questions that we can use spatial analysis to answer. And so you as a policymaker can probably articulate more examples that are kind of written in the language of whatever policy topic it is that you're concerned with. So these are some other examples. Where are the sharpest boundaries between affluence and poverty? Where do we find anomalous spending patterns? What are contributing factors to diabetes rates? Where should evacuation sites be located, et cetera? So you as a policymaker, probably can articulate that very quickly. What would take more skill is translating those questions into the sort of spatial analysis version. So interpreting the policy question into things like where are hot spots or cold spots, where are spatial outliers, what variables predict a phenomena, which locations are furthest from the problem, and then being able to translate that into the proper tools to use and models to create to answer those questions. So this is a skill set that GIS analysts have. And so to understand how to do this, we really need to develop a language of spatial analysis. And just like any other language, it can take some time to learn. But once you have sort of these basic building blocks, this basic vocabulary, it becomes easier to communicate many of these ideas. So it's fairly simple. There's sort of 6 categories, and underneath these 6 categories, there's a total of about 26 questions that you can combine in different ways to answer, almost an infinite number of problems. So we'll go through each of these 6 in a little bit more detail. But basically, if you start from the bottom, the understanding where, that's sort of your first order analysis. And as you move up the list, you're doing more and more sophisticated types of analyses. So let's take a closer look at each one of these. The first category is understanding where. And so again, the first step in your analysis might be simply mapping where things are. Where are people, where are assets, where are phenomena occurring across the globe. And so, we might often call this dots on a map, right? Can seem simple, but at the same time, it can still answer a question, right? And so then you might go a step further and say where things vary, where are there patterns in your data. We might term this comparative maps. And those comparative maps take advantage of different approaches to symbology, like color and size and dot density, for example. And they allow you to kind of further understand the spatial variations in your data. And then we also want to consider the time component as well. So, does the location of things change over time, or is it the same? So it's not just the spatial, but it's also the temporal, and you'll see that throughout those other categories as well. So comparative maps are really one of the most common types of maps that you probably make, oftentimes in the policy space, and really across any space. So I wanted to talk a little bit more about them because they're so widely used. And so many of the things that we're mapping, so much of the data that we're mapping is really driven by people, right? It's tied to demographics, it's tied to human activity. And so I want to make a pitch for addressing this common pet peeve where we look at statistics, we look at comparative maps to look at trends and data, and so often it just aligns with maps of population. If we're mapping kind of raw numbers, raw counts of things, we're basically looking at a map of population. If you mapped, infrastructure or spending or demographics, you're going to end up with what basically looks like a policy map or a population map. So we want to be careful about drawing conclusions from those types of raw data maps. So, we tend to I like to make a pitch for kind of normalizing your data and again, not just looking at the raw counts and factoring in that population to your comparative maps. And we'll see an example of this. I'm going to go ahead and show a couple of demos of comparative maps so that we can look at this issue a little bit more closely. So in this example, I've mapped just some statistics against congressional districts. This is data from a couple years ago, but I just picked out some random categories of statistics from Esri's demographics. So this map is a map of population growth rate. And you can see right now, I kind of have it broken down into 1 to 2%. And the dots are, the center of the congressional districts, and the size represents that growth rate. And so if I look at the choices that go into making this type of map, we can vary the size of a dot, or in this case, since it's polygon data, we can also shade in the boundaries. We'll look at an example of that. But we have options when we make these comparative maps and we're choosing how we want to style these maps. We have a lot of options as to how we break down that data and classify it. So we could do a whole nother webinar just on classification methods. But basically, there's several options available to you within the Esri system. And depending on what you choose, notice as I click through these, my map changes drastically. So we can derive very different interpretations of the same data, just depending on how we classify that data on our visualization. So there's best practices out there documented for when you might want to use these different types of classifications. For example, equal interval is almost always used for temperature maps because it makes sense to kind of break things down and maybe 10-degree chunks or something like that. But other times it makes more sense to use a different type of classification. When I first built this map, I ended up using manual breaks. If I go back and look at that initial classification, it's really an equal interval because I'm jumping up 1% in each class. But I wanted nice, clean, round numbers on my legend, so I did a manual break. But just be aware when you're doing these comparative maps that there's some subjectivity into how you want to classify them. Another example, this is using the counts and amounts colors instead. So rather than putting a point over our districts, I'm just shading in the boundaries, and this is showing me a ratio of basically a percentage of the child population, children in each district that get their health insurance through Medicaid. And so in this case, I pulled out American Community Survey statistics. Again, we have a raw number, and then I compared that to the total population, children population in that district in order to create a ratio. And again, there's tools within our system that make that easy to do. So I had each of those variables as an attribute of my data. When I go into style it, I can choose to add multiple variables and then do a comparison. So creating a ratio of one attribute to another. So again, this will show me true patterns in the data and not just the raw counts where we would expect to see higher numbers in more populous districts, right? So that's one example. And then another example, just to drive home this idea of normalizing your data. These are crime statistics from the FBI for cities across the country from 2015. And again, right now I've just got each of these points styled by the total crime, so the total number of crimes that occurred across all different categories. And you can see, most of these dots are the same size and they're pretty small, but we have larger dots in areas that you would expect, right? So major metropolitan areas like New York, Chicago has a larger dot over it, and LA. And that's again because crime is a human activity. So we're naturally going to see larger counts where we have higher populations. So again, the best way to represent this data is to factor out that population and normalize that data. So I could do what I did in the last map where I have a population variable and I do a comparison. With this data set, I actually went ahead and created a whole new column, a whole new attribute called rate. So I can do a rate per 1,000 people. And so if I use that instead to drive my symbology, you can see that the map changes drastically. If we look at New York now, the point for New York itself is no smaller, no bigger than most of the surrounding towns. Whereas Wilkes-Barre, for some reason, has a really high ratio, really high rate of crime. So it can pull out these trends that you wouldn't naturally see just by looking at the raw numbers. So again, just a plug for, especially for anything dealing with human population, human geography, normalize that data and take into account the population trend that's driving most of that data. All right. All right, so the next category in our language of spatial analysis tiers is the measuring size, shape, and distribution. So beyond just mapping where things are, we might want to start asking, how big are they or how long are they? So this might be understanding, the size of a land use type, right? So how many acres of this state is forest area, for example? Or extents of wildlife habitat. How far does this particular species extend in the geography? If it's a distribution of something, for example, if you've got a distribution of points, you might want to calculate the geometry of that feature collection. So if you've got a distribution of points across your map, where is the mean center of that distribution? Might be a question that you want to ask. So again, that's sort of the next tier up, next level after just simply placing the data onto the map. Third category is determining how places are related. So what is nearby or coincident? Which buildings fall within a floodplain? Summarizing statistics within an area. So you could take that crime data and summarize it for each congressional district or state or county. What is closest? We talked about the proximity analysis. What's the closest fire hydrant or closest hospital or something like that? What is visible from a given location? So if I'm standing on a hillside, what can I see based on the elevation and terrain of that space? And then again, bringing in the time component, overlapping relationships in space and time. Are things always coincident or are they only coincident at certain times? So let's look at a couple examples of this, what's within and nearby. So in this first example, I have some data on mass shootings across the US. This isn't current. Again, this is a few years old, so it may not reflect more recent incidents. But this is a database from Stanford that they put out. And they have statistics on, number of fatalities and victims and things like that. So I've done a comparative map here. Again, I've sized my dots by the number of fatalities. You can see here in the legend. And so then maybe I want to understand, in each state, what's the total number of shootings or the total number of fatalities within each state. So I've got my state boundaries drawn here in the map. And this is one of those spatial analysis questions saying, what's within an area? So how many points fall within each state and, how many fatalities are associated in total with all those points? So when we do that analysis and we aggregate, we end up with something like this. So again, this is another comparative map now based on state boundaries showing the total number of points or in this case, total number of mass shootings. And again, we're seeing darker colors, meaning, more shootings happening in some of the more populous states. So again, this might be another area where we want to go back and normalize this based on population. So we might do, shootings per 1,000 people or something like that. Again, to show us any true trends about this phenomena across the country. So that's one example of how of summarizing statistics. Another example of this sort of coincident or proximity analysis is finding what is the closest facility or closest feature to some other feature. So in this case, I've got Asheville Fire Department stations, so Asheville, North Carolina, with the red dots. So these are their fire stations, and then the blue points represent schools in the area. So we might want to ask, what is the closest fire station to each school? This might be information you want to provide to the school itself or to the fire station so they know, which schools they're quote unquote serving. Some of them will be very obvious. We can obviously look and see some of the ones that are very close to each other, but others might not be as obvious, especially when we take into consideration the road network. Depending on the traffic and time to drive some of these roads, it may affect which fire station is actually closest. So we can run an analysis that lets us prioritize that and say, based on the road network, what is the quickest, which fire station could get to the school in the shortest amount of time, right? Shortest amount of driving time. And so we can kind of turn on the results from that and show, based on the route that they would take, what's the closest fire station to each school. And we can see some of them aren't really close to any schools, and others are serving, quote unquote, multiple schools. So again, this is useful information for those entities to know about in terms of being able to best serve their community. All right, so the next category is finding the best location or path. So some of the examples here, finding the best location to satisfy a set of criteria. So this is sort of that looking for the best location for a store where you've got several factors that you want to consider, and you want to find areas that meet, the target population you're trying to reach, the distance to, major highway access, and cost of rental space and things like that. Finding the best allocation of resources to geographic areas, finding the best route, path, or flow along a network. So that could be simple point-to-point routing or multi-stop routing. Finding the best route, path, or corridor across open terrain, as we talked about in one of those earlier examples. Finding the best supply locations, giving known demand and a travel network. So this is sort of targeting logistics. So how do we best, allocate a fleet of delivery vehicles to make a series of stops, right, based on the road network. So we'll take a look at a couple examples here as well. So some optimized allocation and routing. So in this case, we're looking at schools again. We have this is around Lincoln County, Mississippi, representing school populations by these census block points. So we know, how many students or how many people or households are at each of these points. And we also know the location of schools in the area. How would we best allocate students to these schools based on their capacity or their ability to handle a certain number of students, right? So we can run an analysis that will sort of allocate those census block points to each school. And so this might help us answer questions around if another school is needed to help serve some of these communities that are being pulled from very far away, for example, these blue lines here. Or if there's schools that can be consolidated. So if one school's not serving that many students, can it be consolidated with a nearby school? Obviously, there's other factors that would go into that analysis, but just purely based on the spatial layout of where people live and where the schools are, we can use this allocation to help inform that decision. This is another example. This is sort of that last one we talked about the kind of multi-vehicle or multi-person routing. In this case, we're looking at it in the context of political canvassers. So now that we're facing midterms, this is sort of timely. You may have canvassers out knocking on your door. How can we intelligently route volunteers, represented by these purple points, to homes or households that they're prioritizing for canvassing because they have a certain message they want to get out. So we know sort of the starting locations of these volunteers, and we know where the homes are that they're going to visit. How do we ensure that, the work is divided evenly, no one's spending too long visiting all their assigned stops? We can prioritize, we can set a limit on, the number of stops that people can make, how long they're spending at each stop, what their total workday is, those types of things. And again, of course, taking the road network into account, if they're walking versus driving, what are passable streets that they can navigate on, and come up with an intelligent route for each of them, along with numbered stops. So what is the optimal path, optimal order to visit each of those stops? So again, this is a fairly sophisticated analysis that would otherwise may not be intuitive all the time for people to figure out just on their own. So very valuable again for sort of logistics planning. Alrighty. So the next category is detecting and quantifying patterns. So questions under this category are things like, where are the significant hotspots, anomalies, and outliers? So where do we find things that stand out in our data? What are the local, regional, and global trends? Which features or pixels are similar? How can they be grouped together? This is done a lot with land use classification, looking at imagery and classifying pixels based on their values to come up with different types of land use. And are spatial patterns changing over time? Are those hotspots constant, or do they change over the course of a year or over a longer time extent? So hotspots become a pretty useful tool. We'll echo back to some of the stuff we've already talked about, looking at a hotspot analysis. So I have a map here of, these are hospital referral regions. So these are sort of administrative boundaries used by the Department of Health and Human Services to sort of aggregate, major metropolitan areas and where hospitals are serving a community. So I've got statistics from the Centers for Medicare and Medicaid Services on the cost of a major joint replacement and what percentage of that cost is covered by Medicare. So that's what we're looking at here. This is the average percent covered by Medicare for that procedure in each of these referral regions. And again, comparative map, I've shaded it. The darker areas mean a higher percentage is covered. But as we saw before, there can be a lot of subjectivity in how we interpret this. So again, if I look at those classification options, changing this can change how we as humans interpret this map. And so a sort of safer way to draw a conclusion about whether there really are trends in what we're seeing here is to use a hotspot analysis. One other thing that trips us up a lot of the times is some of these features can be quite large. So for example, this referral region around Billings, Montana is just simply a large feature. So our eye is naturally drawn to that. So again, when we're just relying on our human brain to interpret this, we can be thrown off by that as well. So using a hotspot analysis really helps eliminate that subjectivity, and it finds the statistically significant hot and cold values, in this case of the average percent covered. So if I turn on the results of that analysis, we get something like this, where we're roughly right that the northern part of the country seem to be darker general, meaning that there's a higher percent covered, whereas the southern portion were lighter colors, not as much covered. But this really helps reinforce those interpretations. And you can see, for example, that Billings is a hotspot, but it's a fairly weak hotspot compared to some of these other ones. So if we look at that legend, we're color coding these referral regions by the confidence interval. So anywhere that's the white color is really a not significant in terms of that value. The red colors representing higher values, hotspots of higher values. So this really helps us have confidence in our interpretation of that data. Okay. So the last category, sort of the most sophisticated, is making predictions. You can see there's a number of examples here, a number of questions that we can answer. Given a success case, how do we predict similar locations? So if you have a really successful retail store, what are the attributes about that store that make it successful, and where do we find other stores that we would expect to do well, that are similar enough to that well-performing store? Finding factors that explain observed spatial patterns. So this is the sort of diabetes example. Diabetes rates vary across the country. Are there, behavioral and environmental factors that can help explain that variation? How do we quantify that, and how do we say which ones, which factors actually do contribute to that phenomena, and how strongly do they contribute? So some of them might be more weak of a contribution than others. Interpolating a continuous surface from discrete observations. The classic example here is a rain gauge. So, we've got rain gauges at discrete locations across the country, but we can interpolate that data to make an estimate of what the rainfall would be anywhere in the country at any point. Predicting how and where objects interact, how and where objects affect wave propagation, where phenomena will move, flow, or spread. This might be hydrology studies, so how does water flow down a hillside, and predicting what if. So if one incident happens, how does that affect a neighboring or a coincident phenomena? So again, this is sort of the top tier in terms of sophistication of an analysis that you might do within your GIS. So as we move through, the spatial analysis process, we kind of go through these steps, and this is really sort of aligned with the scientific process, if you're familiar with that, right? And this is a proven approach to solving problems. And we always start, as we said, with asking questions. That's what spatial analysis does, helps us answer questions. So that's where we need to start. So we formulate a hypothesis or a spatial question. We explore the data. So examining the data quality, the completeness, any other scale or resolution limitations that we might want to consider. This can help us determine, what type of analysis can be supported if your data is not complete enough, or it doesn't exist at the geographies that you need to ask the question that you want to ask. That can lead to some other processing that you need to do. Then we'll analyze and model. This is really that green chart that I showed where you've got your policy questions, and then being able to translate that, break that problem down into solvable components that we can model with these geospatial tools. So translating them into that language of spatial analysis, and then executing the tool to answer those spatial analysis questions. Then we need to interpret the results, right? So again, if you've worked through the scientific method, that's another part of this. So evaluating and analyzing the results in the context of the question posed, in the context of your data limitations and accuracy. So again, there's still always some interpretation done by human beings with a lot of this. And spatial analysis is a continuous and iterative process. So we may need to repeat our analysis with different parameters or different input data. We may, our analysis may lead to further questions that we need to then go back and do a separate analysis on, right? So it's an iterative process. Then we need to present our results. Best information becomes most valuable when it's effectively communicated and shared with a larger audience. And then of course, the whole goal of this is to make some sort of decision. And, going back to what we started off by saying is, spatial analysis used to support that decision-making process. And helps to integrate all this data and lead to an understanding that can drive decision making and action. So I want to talk a little bit about data resources. Obviously, we've shown you some examples that all require some sort of data. And that data can basically include two different categories. We can talk about physical geography. These are your ologies, so ecology, climatology, meteorology, all that stuff. Environmental data, landscape data, those types of data sets. And then we also have human geography. So these are, again, all those things that trend with human populations, demographics, health, transportation, economics, politics, etc. So there's, two different sides to this, but ultimately, there's a wide variety of data sources out there where you can find some of this. Some of this might come from your own organization, right? You may be the owner of the data itself that you're analyzing, but you oftentimes need to reach outside your organization to find other resources. So Esri provides what we call a living atlas of the world. This is really where we're making an attempt to create a sort of curated repository of content that's readily available throughout our platform. So we either Esri creates the data layers in our system where we've gotten the data from some authoritative source and kind of just made it ready to use within our system, or our user community itself has submitted information. So there's a lot of authoritative agencies and organizations that are continually submitting their maps and their layers into this system, and Esri kind of provides some quality checks on it to make sure that it's complete and usable and reliable and that sort of thing. So it's constantly growing and changing. We have new submissions all the time. But these are some of the categories there on the right where we're curating some of this content. And again, it's available to our users, any of the users of our platform. So we'll show you how you can access some of that information. I also want to call out another category specifically, which is demographics. Again, so much of what you're doing as policymakers is revolving around how it impacts human beings. So demographics can play a key role in that. So Esri provides some of these demographics in the Living Atlas as kind of pre-drawn layers, so visualizations that we've done of some of these statistics, but we have many thousands of variables for the US and globally as well available for you to enrich your own data with. So if you provide boundary information, an area of interest, we can tell you about the demographics within that area. And so we include census information from Decennial Census and American Community Survey. Esri has its own team of demographers that creates updated demographics for the current year and 5-year predictions for a lot of those decennial census variables. We also create a data set called Tapestry Segmentation. And then we source other data sets from third-party companies. So a survey company to provide behavioral data, spending data from the Bureau of Labor Statistics, and other licensed data around things like crime. So all of this data can be queried within our system at various endpoints, but it's a really powerful tool to help augment your analysis. So we'll take a look quickly at some more resources around these, the Living Atlas data and the demographic data. So if you just go to livingatlas.arcgis.com, this is sort of our landing page for people to read about Living Atlas and browse the content there. So this is just sort of the overview page. But if you go to browse, this is where you can see all these different categories. We can filter and explore the content by region. So if you're only interested in the US, you can filter that down. And then we can see what type of boundary information we have. Again, what some of those pre-rendered demographic variables are. Information on infrastructure. So for example, transportation and railroads and things like that. So lots of data here to explore just so you can sort of get familiar with what's available there. This is a good page to explore. And I'll show you in another example where you can pull that data into your map. So when you're actually doing a visualization or doing an analysis, how do you access the Living Atlas content? But I did quickly want to show our sort of demographics documentation page as well. So, we get questions all the time about what variables we have and what's the methodology behind them. So you can come and explore any of these categories in terms of the vintage and update frequency and things like that. And so these become, again, statistics that you can access from anywhere. And again, we'll come back and show one of the places that you can access them. So we've talked a lot about where to perform spatial analysis, or we've talked about the results of spatial analysis and how to think about spatial analysis and talk about it, but where do you actually run it? How do you actually get access to these tools? So if you're new to spatial analysis, we would highly recommend starting with our ArcGIS Online platform. So this is a little bit easier entry bar. It's got 28 analysis tools, including things like aggregating points, so doing that summarization, geo-enrichment, which is that process of adding those demographic variables to your data, overlaying to find intersecting features, the hotspot analysis, the find nearest, which we saw some examples from. Those are all things that you can do in the online environment. And then if you need to go further, if you need to do something more sophisticated, or maybe you want to, script or model a workflow, you can move into our desktop environment. So our geoprocessing tools, geoprocessing is just a sort of another term for spatial analysis. It's, kind of the desktop lingo for running spatial analysis. This has several hundred tools. So you can see all the different toolboxes there in that screenshot that each have multiple tool sets, and each tool set has multiple tools. So there's many available there. And a lot of them, address more problems around sort of data management and working with other parts of the Esri platform. But there are, more true spatial analysis tools in the desktop environment than we get in the online environment. For example, doing the, regression analysis would be something that you probably do in the desktop environment. And it also provides what we call a model builder interface. So this is a really neat component that allows you to chain different tools together to capture a workflow or tradecraft. So if you know you need to execute a series of tools in an order, you can chain those together in a model, and then it becomes something you can save and repeat in the future. So you don't have to, execute each tool individually every time. And if you want to go even further, you can leverage Python scripting through the desktop environment. So you can, script your analysis, and you can even integrate with external analysis packages as well. For example, the R statistical analysis package is something that you can integrate. But again, if you're just getting started, we recommend working in ArcGIS Online. So I'll demo real quickly, and I've been showing all these demos here in the online environment. But to show you what some of these tools look like, for example, doing this hotspot analysis, here in our map viewer, I can either turn on the analysis tool just by going to the analysis button, or if I know I want to use this layer as an input to a tool, I can open the perform analysis button from right underneath it. And if this is, in this case, we're running a hotspot analysis that's under our analyze patterns section. So I can find that tool. And one thing I want to point out, we've put a lot of effort into, creating some easy to read documentation about these tools. So if you're wondering what a tool does, if you click that little blue eye icon, you get some nice human readable language about what this tool is doing. And then when I open the tool, you notice each step of the process has that same sort of information window. So if I'm unclear about what this option is, I can click and get more information to decide how I want to enter that parameter, right? So again, I just fill out, in this case, I want to calculate hotspots for this layer. And rather than finding the clusters by the count of provider, I want to do it by the average percent covered. If I wanted to normalize it, I could. And then I give a result layer name. Each of these analysis tools will output a new hosted feature layer in your content, if you're familiar with ArcGIS Online. So you'll get a new layer that contains the result of your analysis. And I'm not going to execute it today just for the sake of time, but the layer will appear here as it's kind of grayed out and spinning while it's processing, and then the result will come back. And depending on how much data you're analyzing and your sort of network bandwidth, that can impact the amount of time that it takes an analysis to run. One other example I wanted to show was how you access the Living Atlas content. So in this case, I've got some data from the ACLA database, the Armed Conflict Location dataset. This is again a dataset that actually comes from our Living Atlas as well. We've brought in from a public source. And so these are points of armed conflict incidents across Nigeria. So if I wanted to summarize this, I can perform analysis. I can go to summarize data, and there's my aggregate points tool. And so it's already populated my input layer there. Now I have to choose what I want to aggregate to. And we have some options here. If you want to define the polygon area, if you just want to aggregate to kind of a square grid or a hexagon, you can choose that. But if I want to aggregate to the administrative boundaries for Nigeria, I could go out and try and find that data source somewhere, but actually have it available in the Living Atlas. And we've kind of baked that option into a lot of these analysis tools where it's appropriate to be leveraging Living Atlas content. So I can choose a Living Atlas layer. It's going to kind of filter and just show me, within this map area, what are the boundaries that I could aggregate to. So I'm just going to search quickly for Nigeria, and I can find those state boundaries and select those. Again, add some additional summary statistics, and then choose my output layer name. Again, not going to run this, but I just wanted to point out that's one way to access the Living Atlas content for your analysis. Otherwise, you can just add it directly to your map from the add button. So I can browse the Living Atlas here, search based on a keyword, do some filtering if I know I'm looking for environmental data, for example, particular layer type, particular area of the world. So that's one way to access the Living Atlas. just as an example, this is an aggregation to hexbin, so that's what the hexbin option looks like. And then I'll finally just quickly point out the geo-enrichment tool, the demographics. They can be accessed through this data enrichment category, the enrich layer tool. So this will let me browse for variables. In this case, for Nigeria, we have some key categories there. If you looked at the United States, you see we have many more categories and variables available here. So I could provide it with boundary information that I want to enrich and then choose the statistics. So just wanted to quickly point out where you can access some of those data resources that we talked about. So just wrap up real quickly here. One last slide. So some resources, that language of spatial analysis that we talked through, that's actually an ebook that we provide online for you. So that's the URL if you want to grab that and read more in depth about each of those different categories of spatial analysis and the questions that you can answer. And then for those online tools where you can actually perform spatial analysis, I just wanted to reference the documentation for each of those. So again, if you are working in online and you are not sure what a tool does and you want to know more about it, you can read the documentation there. So with that, thank you very much for attending the webinar today. We're at 10:45. We can take a couple questions if anyone has any, but otherwise, thank you so much for joining.
Well, thanks, Bonnie. And as she mentioned, we can certainly take some questions. There's a question tab on the widget that each of you is logged into. So if anyone wants to submit something for Bonnie to tackle, we'd be happy to do that. We'll give it a minute here and see if we get any questions.
There is a question.
Yeah, looks like we got one here.
Is there any way to favorite living atlas layers, ones that you use frequently? Yes, there should be. So in ArcGIS Online, there is a way to find content. So let me go back to, let's see, I think this one. So this had this states layer. So this is a boundary layer that I use a lot. If you actually go to the item details page for this, let's see, owner, strengths, yeah, add to favorites. So if you go to the details page for any of those living atlas layers, right underneath the thumbnail, you can click add to favorites, and then that'll be added to your favorites. So then if you go to content, I believe you'll find your favorites tab here. So my favorites, and there's the USA states that I just favorited. So that's an easy way to sort of bookmark it for yourself. Good question.
Yeah, thanks for that question, Taryn. Seeing no others, I want to again thank Bonnie and thank all of you, our viewers, for joining us on this webinar. Our next policy webinar in this series, which has proven to be very successful, is going to be in 2019, and we will send out details about those future webinars in the coming weeks. So thanks again for taking part today, and we hope you have a great fall. Bye-bye.